Hello and welcome back to Think Code and More. So yes, I did change the channel name and it's not going to be another cubing video. You might see something different right now. It is me or my face cam, and then underneath is going to be my cousin's face cam named Devanshi, and she is in high school. She's in Canada, and she helped me learn or explain to me why the cosine of 90 degrees is always 0. So this is trigonometry. I hope I said that right. Okay, and I'm also going to put a few timestamps in the description for each and every separated part of this video, or each and every separated part that my cousin Vanchi is explaining. And what is a cosine, Vanchi?
So cosine is basically a trigonometric function that can be determined by a ratio. Due to you can use a ratio for a side of a adjacent of a right angle triangle to figure out an acute angle with by dividing the adjacent by the hypotenuse, basically.
So
that would be something like, in this case, so if we're finding the cos of this angle over here,
call that theta. So this is what theta looks like. It's like a small circle with a line going through. And you may explain what the rest is.
So let's just say we're trying to find theta here, and if we use a cosine ratio, that would be the adjacent of it over the hypotenuse, and the hypotenuse is the longest length always. So the one adjacent to it is basically the one beside it, which is 4 in this case. And so what we would do is we're going to basically, in this case, if we were to do cos of theta.
You can just write theta, I guess.
I don't know how to write it. I'm just going to do cos of x equals.
So just think that theta symbol is equal to x.
So that would be the ratio of that. So, and if we wanted to find what the theta was, we would just do the inverse of it. So x would equal to cos.
You could do to the power of, so it would be shift, minus 1, 4 over 5. Then you would use this in a calculator.
And if you put that in a calculator, you would get.
And Vanchi, do you have your calculator next to you?
That would be about 36.9 degrees.
So now we know theta is 36.9 degrees. It's a round. It's usually just a really big decimal, but it's around 36.9 degrees.
Yeah, so around 37 degrees.
So that is how we figure out the cos of an angle, like theta, and doing the inverse of that, we can figure out what the angle is equal to. So now the main problem or issue or mystery about figuring out what the cos or the cosine of this 90-degree angle, which is right here. I'll make this full screen. So this 90-degree angle right here is because we have two different sides that are adjacent to it. So we never knew which side would we pick. But looking at the small diagram, which we are now going to explain.
Okay, so to explain this diagram, what we're going to do is we're going to look at it. So I just made it so you guys can see clearly what's going on. So since we know that in a triangle, the makeup of the angles would equal to 180, right? So I have an angle here that is 90 degrees, and I have another angle here that is also equal to 90 degrees. And as we discussed before, that to make cos 90, to prove that cos 90 equals 0, we're going to need two angles that are 90 degrees. So since the two angles are already make up 180 and 80 degrees, the last angle over here, has to equal to 0, because both of the 90 already make 180. That makes the most sense for this triangle. So like to put the ratios in, like to show you what the ratios might look like, let me show you for sine first. So if we were to do it with respect to alpha here, it would be sine, and since alpha is equal to 90 degrees, we're going to, since sine is opposite over hypotenuse, in this case our opposite is b, and our hypotenuse is a over here. So if we were to do that, since our values here are given as a equals b, and a equals 1 and b equals a equals 1 and b equals 1, so sine 90 would also be 1 over 1, which is equal to 1. And that's actually true. If we were to calculate, sine 90 does equal to 1. Now, if I were to do it for cos, we would use a similar mechanism where we would do cos of, again, 90 of alpha over here, which is equal to adjacent. So adjacent in this case is the value of c over here. So to do that, we would, so since c over, and since cos is adjacent over hypotenuse, that we c over a, which is equal to 0 over 1. And as we know that anything over 0 is equal to 0. So 0 over 1 is equal to 0. Now, this is just a way we could do it. Now, another way we can do it is respect to beta here. Okay, so with sine, it would be sine 0 in this case. So the opposite would be c here over the hypotenuse. Since this is the hypotenuse, we can't have this be our opposite. In this case, this would be our opposite. And so in that case, it would be c over a, which is equal to, so sine 0 would be then, which is equal to 0. And that is actually true. Oops, I made a mistake here. 0. Which is actually true. If you were to do sine of 0, you do get 0. Now, if we were to do sine of,
or cos of 0?
Or cos of 0.
Yep.
That would be equal to, in this case, and that would be b over a. And that is equal to, I keep saying that is equal to 1 over 1, and that would be 1. And if you were to calculate cos to 0, you do get 1.
Okay, and that's the end of the video. So make sure to leave a like and subscribe for more videos about iOS development. I'm now going to be probably starting to teach, and gaming is coming soon to this channel. Game development, we've already started, and there's nothing else. Professor's Cube video is also coming out really soon, how to do the red center, and, well, actually not the red center, the blue and, I can't talk, blue and orange centers, and that is it. Just at the end, I would like to thank my cousin Devanshi for helping with this video and explaining why the cosine of 90 degrees is always 0 and a few more things.